So today we would like to talk about the introduction to the modulation, and we are now in the introducing a very important topic called modulation. We're going to talk about along with the end of the semester, okay? And now we would like to see the firstly some in the last lecture we have the module overview, the basic definition, the band pass, the band baseband component from communication system, and this lecture we can will introduce the channel degradation, signal to noise ratio, the EM spectrum, the need for modulation, and types of modulation. So there are two types of channels, which is physical channel and electronic waveform channel, where the physical channel can be a wind, the coaxes, the cables, optical fake, or optical fibers, and the wireless waveform propagation channel, like the wireless broadcast channel, the radio mobile radio channel, satellite, and so forth. So this is very important. This slides we are going to have three kind of channel degradations, which is called interference, distortion, and noise. So the interference is the contamination, which means a mix of the channel by extraneous signal, which means that if you are talking to your mother and maybe you are hearing other people's voice, because there are some interference between other valid signal to your own signal. Therefore, it's like interference. So there are some. This is two signal involved in one. It is different from noise, which is the second one. It is the random, unpredictable, and undesirable electronic signal from natural sources. This is the noise superposition with your signal. So that's very different. And the distortion is generated by the channel itself, which means that due to the channel's if in order to be in the channel, we need to clamp it or lift it or do maybe the lower signal is with eliminated, or the higher signal is maybe the filtered away. So that is the distortion part. And the bandwidth of signal is the range of frequency that it can transmit with reasonable fidelity, which means that in these courses, we are going to distinguish the bandwidth from the one we introduced last semester. That is very important. So in this semester, we are going to introduce several key things. The first thing is the bandwidth. Bandwidth of the signal bandwidth and the bandwidth of the channel. So what the bandwidth of the signal means in signal and system we see the bandwidth. Let's say this is the lowest and this is the highest. The bandwidth is just here. However, we would like to extend this concept by a bit more. That's like, what if the signal is like this? What if the signal is like this? So the bandwidth, originally we think the bandwidth is here. But it's wrong. Now we would like to argue that the bandwidth here is from the highest to the lowest. Okay, and this is the signal part. And now we would like to see the channel bandwidth. The channel bandwidth is also the signal bandwidth is limited by the signal, and the channel bandwidth is limited by the channel. Where the channel means that this is the frequency, lower frequency. It is a valid band within that can be transmitted as a valid maybe the period of the frequency, the span of the frequency between the channel that can be transmitted within the channel. So let's continue talking about the bandwidth of the channel, the baseband channel. So this is also worth noticing that the bandwidth of a baseband channel is the highest frequency contained in the channel, because the this is a concept that we introduced in the last semester in the signal system, which is the first demonstration I made. And the bandwidth or bandpass signal is difference between the highest signal and the lowest signal. Yeah, this is the second demonstration, which is the concept we are talking about in the communication system. And the bandwidth can be shortened, abbreviated as B, and it's usually measured in 3 dB or half power point. What is a half power point? And the maximum rate is proportional to the bandwidth. Maximum. What if the bandwidth is high? The bandwidth here is I think is the, because if you have more bandwidth, you can transfer more data. This is actually very intuitive. And the signal to noise ratio (SNR), signal to noise ratio is defined as the signal to noise ratio is defined as the signal divided by the noise. The signal to noise ratio is calculated as follows, which is signal to noise ratio equals to 10 times log base 10 of signal amplitude. I think it's signal amplitude divided by the noise. I think it's amplitude or power. Let's check out. I think it's power. Sorry. That's very important. Just keep in mind it's power. Okay, let's continue that. Let's look at some example. That's the signal to noise ratio, and the unit is dB. So, what if the power is 100 times of the noise? So this is S divided by N in power is 100, and log base 10, 100 is 2. So this is 20. This one is 20. And communication signal, we have the transmitter, the communication signals, and the receiver. We have the signal bandwidth, which in order to transmit the data faster, a signal has to vary more quickly. A channel bandwidth. A signal bandwidth is in order to transfer the data faster, the signal has to vary more quickly. A channel bandwidth is a channel or medium that has the inherent limit on how fast. Yeah, the channel limit is the limit of the channel, and the transmission impairment, which is called the signal attenuation, signal distortion, signal noise, and interference from other noise. And it limits how accuracy which limits the accuracy of the measurements on the received signal. And the channel bandwidth limits how tightly input ports can be packed. I'm not sure what that means. Maybe it's like sampled or something. And then we talk about modulation, which is the process of encoding information from message source in a manner suitable for transmission. Modulation is called frequency shifting. It generally involves transmitting a baseband signal to a bandpass signal, and the baseband signal is called modulating signal, and the bandpass signal is called modulated signal. That's very important. And demodulation is the process of extracting the baseband message from the carrier to the receiver. And the need for the modulation is that the baseband communication we can transmit signal as it is, and the signal the antenna length is in the order of a quarter of the wavelength. That is very important. The wavelength, a quarter of the wavelength is called the antenna length. The channel degradation consists of the three parts. It's called interference, distortion, noise. Division of the frequency band is or the channels. The division of the frequency band that we are going to talk about later, and the need of the radio frequency carrier. Yeah, that is going to be more much better. I mean, that is the one that helps us. So the electronic magnetic spectrum is a speech signal that contains frequency up to 8 kHz can be transmitted at the beat. If the speech signal containing a frequency component up to 8 kHz were to be transmitted at a baseband, calculate the waveform and hence appreciate the antenna size required to transmit to receive such radiation. So let's see what if it's if the frequency is higher, I see. So the antenna is larger. Yeah. The frequency is the antenna is larger if the frequency is lower. If the frequency is larger, then the antenna is lower. That is basically. I think it's dependent on the. I think it's dependent on the antenna size to determine that, and I will determine that later. So inside the radio wave spectrum, we have the AM is around 500 kilohertz. The remote control toy. This is you can see the garage door opener is here. Is all above the 500 megahertz, and the Bluetooth is 2.4. And let's continue talk about in order to go to the dark side of the moon, we need a relay satellites. And here, this is how long does it take from the signal to travel to the Chang'e 4th lunar probe. So the speed of light is 3 times 10 to the power of 8, and the t equals to the distance divided by the v. The distance here is let's see how far does it take. It's around okay, it's and 3 times the power of 8, and let's move this 1, 2, 3. Then this is cancelled out. So this is around 1 to 2 seconds. So in order to transmit the signal, we need so this is answer is B. And on 6 megahertz radio message to the Chang'e 4 lunar probe lasts for 30 seconds and is transmitted at a frequency of 3 gigahertz. What is the wavelength? So wavelength we can follow this method. I think C equals to F times lambda. Yeah. So C is the frequency. Let's look at the frequency. The frequency is so this is we always using the transmitter carrier frequency, which is 3 times 10 to the power of 9. 3 times 10 to the power is gigahertz. So it is lambda 0.1 meter. I think the answer is 0.1 meter. The answer is 0.1 meter. I remember that. The wavelength is the lambda here, and the frequency is 3 times 10 to the power of 9, and the answer is 0.1. And I will just clarify with the valid. And if the radio station were to broadcast music at a baseband of frequency, which means it's 15 kHz, how large would the antenna be? So let's continue calculate the antenna. Let's calculate the wavelength first. So it's 3 times 10 to the power 8, which is the frequency 15 times lambda. So lambda is so this is 0.2 times 10 to the power 5. So lambda is 200 meter, and 200 meter divided by 4 divided by lambda, so it's around 200, right? No, it's this. Yeah, 200. Yeah. So this divided by 4 is 5 kilometers. Yeah, 5 kilometers. And if the radio station was to broadcast its music at bandpass frequency, how large would the antenna size to be? So it's the bandpass frequency, right? So it's 96.7 megahertz. Let's look at this. So the 3 times 10 to the power of 8 is equal to the lambda times what is the frequency? The frequency is megahertz. Megahertz means 6, right? Megahertz. Yeah, megahertz is 6. So this one approximately to the power, or maybe it's approaching to the 8, right? Lambda is around 3 meters. And then let's look at the 3 meters. What is the 3 meters divided by 4? It is 0. So the antenna is around 0.75 meters, which is around 75 centimeters. So in order to transmit, in order to demonstrate the transmission of information, we need the carrier generated at the transmitter, the carrier modulated with information, the digital analog or digital, and the modification detected. So this is the, we need the carrier we need the carrier generated transmitter, and we need the carrier modulated with information about the analog and digital signal and the notification detected. So the thing is that we have the modulator, we have the carrier, and we modulate them together. We can do the amplitude modulation and the frequency modulation based on some superposition techniques, which we're going to be illustrated in the next class. So this is actually the overview of this courses, and it's maybe the sub-hierarchy diagram of the modulation. Well, in the modulation, we have the analog and digital modulation. And the digital, we have ASK, FSK, PSK. I do not know what that is. And the analog signal, we have the amplitude modulation, angle modulation. We have the AM, the DSB, the SSC, VSB. The analog modulation, we have the amplitude modulation, the angle modulation. We'll be looking at each modulation in the next few weeks. So in these courses, we talk about the channel degradation, the signal to voice ratio, the EM spectrum need for modulation, types of modulation. Next week, we're going to talk about the amplitude modulation. Okay, thank you very much for comment and subscriptions.